All right, here are the video notes for lesson 4.1, our first chapter here in first lesson here in chapter 4, and we're going to be focusing on radians and degree measures. And so this chapter 4 is going to start getting into some trigonometry, and to do trigonometry well here in pre-calc, we need to know radians and degrees. A lot of this lesson is notes, and so I'm going to skip by quite a bit of it and just kind of focus on doing some of these problems. So as we move along here, we get just notes. Big things to note when in this one is that if we're moving counterclockwise, that's going to be positive for us. If we're going counterclockwise, positive, clockwise would be negative for us. We can see that with this diagram here. Moving this way would be like a positive alpha. Going this way is like a negative beta. And the negative theta and alpha, beta, theta are kind of how we denote our angle measurements using those Greek letters there. Here we have this idea of coterminal angles. And really what's happening here is you can do a couple things. You can either add 360 to end up back where we started, or you can subtract. Okay, so there's this negative part and this positive part, and you can see. And the one down here, we have the positive and negatives, where 225 positive is the same thing as 135 negative. And then here we have 330 and 390 are the same thing because they added 360. And here they just did the negative part and the positive part to get in the same place, and that's what we call our coterminal angles. So here then we have our radian measures around the unit circle, and I'm just going to do a quick one. We focus on this unit circle a little bit more in 4.2, but just quickly what this looks like, we would have 0, 30, 45, 60, almost forgot, 90. So you can see 0, it moves 30, and then 15, 15, 15, little increases of 15, and then a big 30. And then we have another 30, so that's 120, 135 in our 15s here, 150, 180, 210, 225, 240, 270, 300, 315, 330, and then back to 360. And that's our unit circle. We're going to be practicing more of that, especially with radians coming up here. Looking at this slide here, how it looks in terms of a grid, where is it positive, where is it negative? Well, from this first portion here, that would be like 0, theta, 90, so everything between 0 and 90. In radians, that looks like 0, theta, pi over 2. Pi over 2 is the same thing as 90, and that's where we're going to have positive and positive. On this side here, we have 90, and the theta is between 90 and 180, so that's pi over 2, theta, pi. That's 90 and pi is 180, and that would be with negative comma negative comma positive. Here in the bottom, we have 180, and we're between that and 270, so that is pi, theta, 3 pi over 2. And that's where we have negative, negative, because we're down in that third quadrant, not 1 there, it's negative, negative. And then lastly, when we're in this last quadrant here, we're between 270, can't write today, we're between 270, theta, and 360, so that's 3 pi over 2, theta, and 2 pi, and that's where we're going to be positive, negative. Okay, so that chart there is nice. You can see that in your notes, your written notes, but that's just how it works, and that's kind of an introduction to how we can label. Okay, 0 is 0, 90 is pi over 2. You see pi over 2 here is still 90. Pi is 180. So you can see like times 2 here. 2 times 90 would be 180. 2 times pi over 2 gives you pi, and we actually kind of see a pattern there, and we can talk more about that when we get to unit circle. Okay. Here are some coterminal angles and radians, and so if we want to find a coterminal, what we can do is we can always add or subtract 2 pi, because 2 pi is the same thing as adding or subtracting 360 degrees. So here, if we wanted to find the coterminal, I'm just going to do 1 because you can see these in your written notes, but if you wanted to find a coterminal here, what you can do is you can just subtract 2 pi, and what that is, that would be 13 pi over 6 minus finding a common denominator here. We need to find a common denominator. And so that becomes multiplying, this is 2 pi over 1 times 3 over 3. So that's 6 pi, oops, wrong. We have to multiply this by 6 over 6. So this is 12 pi over 6. Common denominator now I can subtract, and that gives you pi over 6. So pi over 6 is the same thing as 13 pi over 6 because that's a coterminal. We just moved 360 degrees around, ended up in the same spot. Okay. You could also add them. So like if I wanted to on this one, I could add 2 pi and do the same exact thing and find its coterminal. And you can see, I think I subtracted both in the notes I posted. Okay. The other thing that we have these, and you might remember these from geometry, we have complementary and supplementary angles, meaning complementary is 2 angles that add up to 90, supplementary is 2 angles that add up to 180, and we do that with radians now. And so how I write this to find the complement and the supplement, again, I'm just going to do one, you can see the other in the written notes. As I say that 2 pi over 5, so I say plus x plus some angle I don't know has to equal pi over 2, because pi over 2 is 90. So really what I'm saying is 2 pi over 5 plus some angle I don't know equals 90 or equals pi over 2, and I can find that x by subtracting. And so what I end up getting is then pi over 2 minus 2 pi over 5. I got to find a common denominator, so multiply this by 5 over 5, multiply this by 2 over 2, so I get 5 pi over 10 minus 4 pi over 10. And I get pi over 10 would be the angle, would be the complement. Pi over 10 would be the complement angle to 2 pi over 5, because when you combine them, they give you 2 pi, or they give you 90. For supplement, it works a little bit different. Very quite the same, but a little different. We have our 2 pi over 5 plus x now has to equal pi, because pi is 180. And what we can do then is we can take pi minus 2 pi over 5, get a common denominator here by multiplying 5 over 5, so you have 5 pi over 5, and we end up here with 3 pi over 5, oops, that's not right, 3 pi over 5 being our supplement there. Okay, so just depending, and really what you can do there is if they want you to find it, and you can see I did it both times, I took the pi over 2, subtracted the angle they're giving me, that was for my complement. Here I did pi minus the angle they're giving me to find its supplement. So complement blue, supplement red. All right, big one here, one to take notes on. If we wanted to go from degrees to radians, we do pi over, we multiply by pi over 180. If we want to go from radians to degrees, we do 180 divided by pi. We'll show a couple examples here with maybe 135. I use my calculator a lot on these. And so if I want to go 2 radians, I need to multiply pi over 180. So this becomes 135 pi over 180. And I just put in my calculator that fraction so I can reduce it down. Quite simple. And I got 3 pi over 4 is the same thing as 135 degrees. This will be helpful for us in the beginning stages of doing radians and degrees. This is helpful for us so that we can convert back and forth. Let's go from radians to degrees now. And so I'm going to multiply this one here, negative pi over 2. I'm going to multiply that by 180 over pi. Pi's cancel. This is negative 180 over 2. It's negative 90 degrees. Okay? Again, that method's going to be helpful for us here in the beginning until we have more degree measurements memorized. Here we have a little equation for arc length. That'll be in your notes, written notes. And then here we're going to actually use it. And so what we're going to do, and what I'm going to do is convert that 240 to radians, if I like radians. So 240 times pi over 180. That's 240 pi over 180. Again, reducing down with my calculator here, 240 divided by 180. I get 4 pi over 3. Same thing as 240. Okay. Using my formula here, I can say that S equals the radius, which in my case is 4 inches. 4 times my theta, and my theta is 4 pi over 3. When I multiply here, I get 16 pi over 3. And I believe that's in inches. Okay. Lastly, we have area of a sector. Area of a sector is, again, just an equation that we can write down and have. And then same kind of thing. We have a theta, we're going to have a radius. and we can solve. And so we have a sprinkler on a golf course, sprays water 70 feet, angle of 120. I'm going to convert that 120 to radians. 120 times pi over 180. That's 120 pi over 180, which reduces down to 2 pi over 3. So using my equation, I have 1/2 times my radius squared, and that's going to be 70 squared from my 70 feet, times my theta, which is 2 pi over 3. What I am going to end up having here then is 1/2 times 4,900 times 2 pi over 3. We end up doing, let's see, 4,900 divided by 2 gives me 2,450 times 2 pi over 3. Multiplying here, so top, this is like over 1, bottom, we have 4,900 pi over 3, and I'm going to leave it as that for my answer. And I believe that is in feet squared. Am I working in feet here? Yep. So that would actually be feet squared there. All right, that's it. The updated homework is posted on Google Classroom, so you can work on it there. And the written notes are up there as well. Hopefully that you joined us for class, and if you need more assistance, if you weren't there for class, let me know, and I can always slow down and make additional videos.